Hey there and welcome. Today, we're going to pull back the curtain on, honestly, one of the most incredible and high-stakes construction projects you've ever been a part of. And the crazy thing is, you don't even remember it. We're talking about the building of your own mouth. It's this wild story of biological architecture that all goes down in the first few weeks of your life. And trust me, the details are absolutely mind-blowing. So here's our blueprint for today's explainer. First, we're going to frame this whole thing as a construction project. Then we'll get into building the roof. That's your palate. We'll watch an incredible moment of, well, biological gymnastics. Then we'll assemble the tongue, and finally, we'll tie it all together to see how it created the architecture of, well, you. You know, in the very, very earliest moments of our development, our face and mouth get assembled in a process it's kind of like an invisible ballet. Seriously, every single cell, every little piece of tissue has to move to the exact right place at the exact right time. It is such a high-stakes construction project, and the margin for error, it's basically zero. So, have you ever really thought about it? I mean, that solid roof of your mouth or the incredibly versatile floor, which is your tongue, where did they even come from? Because they weren't always there, right? They had to be built, piece by piece, completely from scratch. And that's what's so incredible. Your palate and your tongue didn't just, grow into the shape they are now. Nope. They started out as a collection of separate little swellings and shelves. It's almost like a biological IKEA kit just waiting for assembly. In those first few weeks, your body had to follow this super precise set of instructions to put it all together perfectly. All right, let's get this construction project started. First up, the roof of your mouth, the palate. And its job is absolutely crucial. I mean, it creates that wall that separates your nasal cavity from your oral cavity. Without that wall, eating and breathing would be, well, a huge challenge. So the whole construction process basically happens in 4 main stages. First, you've got these 2 shelves that start growing downward. Then, bam, they hit a major obstacle. The tongue is in the way. After that, something truly amazing happens. These shelves actually flip upward. And finally, they meet right in the middle and fuse together, forming that solid roof. Okay, so try to picture this. Deep inside the developing embryo, you have these 2 flaps of tissue, right? They're called the palatal shelves. And they start to grow, but here's the weird part. They don't grow across to meet each other. Instead, they grow straight down, kind of like curtains hanging on either side of this big developing tongue. Okay, now we get to what is by far the most dramatic moment of this entire process. You've got these shelves growing down, but they need to form a roof up above. And getting there requires a moment of just incredible, high-speed biological gymnastics. And this is where the whole project hits a massive roadblock. The palatal shelves are just hanging there, vertically, but they can't move into their final horizontal position. And why not? Because the developing tongue is just sitting right there, smack in the middle, completely blocking the path. It really seems like a physical impossibility. So the construction plan has pretty much hit a dead end. How on earth do you build a roof when there's a giant obstacle right in the way? Well, here's what's so amazing. The solution isn't gradual at all. This entire transformation, this movement of the shelves from vertical to horizontal, it all happens in just a matter of hours. It's an unbelievably rapid and perfectly coordinated event. And this is where the science gets really, really fascinating, mainly because we're still trying to figure out exactly how this works. There are a bunch of theories. I mean, maybe the tongue just drops down and gets out of the way. Or maybe the shelves themselves generate the force to move. One idea is they rapidly soak up water, get all stiff and turgid, and that helps them flip up. Another theory is that special cells inside the shelves act like tiny muscles and literally pull them into position. It is just an amazing biological puzzle. So once those shells manage to flip up and get horizontal, they finally meet in the middle. But they don't just, glue themselves together. The cells that line the edges are actually programmed to disappear. It's a process called apoptosis. And this lets the tissue underneath merge together, creating one seamless solid palate. It's like biological welding, and it's absolutely perfect. Okay, so the roof is done. Let's head downstairs and look at the floor. And if you thought the palate was a complex build, oh boy, the tongue is an even more intricate assembly job. We're talking about bringing together parts from totally different embryonic regions. See, your tongue isn't one single piece. The front 2/3, the part you could actually stick out, and the back 1/3, they've completely different origins.
The front bit comes from swellings on something called the first pharyngeal arch. Meanwhile, the back part is built from pieces of the second, third, and even fourth arches. They're basically two different structures that have to fuse together perfectly. And get this, the complexity doesn't even stop there. The actual muscles that let your tongue move around, they aren't even native to the tongue itself. They're basically immigrants. They have to migrate from a totally different region, way back in the neck area, to come and populate the tongue and give it all that incredible mobility.
And you can see this whole multi-part assembly perfectly reflected in the tongue's wiring. It's fascinating. Because the front and back come from different places, they're hooked up to completely different nerves. For the front part, you've got one nerve for general feeling and a different one for taste. But in the back, a single nerve does both jobs. And then you have a completely different nerve that comes in just to control all those muscles. It's like a complex circuit board that literally maps out the tongue's unique construction history. So let's just step back for a second and look at the final product here. What we've been talking about, this wasn't just some abstract biology lesson, right? This was the literal nuts and bolts construction of your ability to eat, to speak, to taste, and to swallow. This is the architecture of you. It really is a microscopic ballet where every single step has to be perfect. Every cell moving, every tissue fusing, every one of those shelf flips. It all has to be timed down to the microsecond. The precision required is just staggering. And the wildest part? It all happens without a single conscious thought from you. And really, that's the main takeaway here. These incredibly complex, functional structures that you use every single moment of every day, they were all built from much simpler, separate pieces, and they were assembled with a kind of accuracy that would make the world's best engineers totally jealous. It really makes you wonder, doesn't it? If the construction of just our mouth is this complex and miraculous, what other incredible, invisible processes are coded into our biology, happening right now, completely out of sight? That's definitely something to chew on. Thanks for joining me.